address here, because this is going to return the actual contract, and we really only want the address. This is going to make our coding a lot more robust for moving between development environments and test end environments and working with scripts in a really effective manner. So now that we have this incredibly powerful function, let's go back to the lottery and figure out what are the different pieces we need in here. Okay, great. We also need a VRF coordinator. So to do this, we're going to go back to our docs.chain.link. We'll go to contract addresses, and we could do mainnet here, but let's also just set this up to work with RinkB. So we'll do Control F for RinkB. VRF coordinator is going to be this address right here. So we'll copy it. We'll go back, and we're going to have to do in our config is we're going to have to add a new network here for RinkB. We'll do VRF coordinator. Will be that address right there. And then while we're doing this, let's also get the RinkB address for our price feed. So Ethereum price feeds, RinkB. Let's scroll down for ETHUSD. ETHUSD, here we go. Grab that, enter, and this will be ETHUSD price feed. Paste that address in here, perfect. So now we can do get contract VRF coordinator .address. Of course, we are going to have to go back to our helpful scripts because there's currently no mapping between what a VRF coordinator is and what its mock needs to be. So we'll add a comma here, and we'll do VRF coordinator, and we need to get a mock VRF coordinator. Well, first of all, we don't even have our mock v3 aggregator, so let's go grab that as well. So we can grab both of these. Again, I'm going to highly recommend going to the Chainlink mix, going into the contracts here, going to the test folder for these different mocks, because these are already set up to work with the Chainlink mix. However, you can definitely go into the Chainlink GitHub as well. Go to contracts, SRC 0.6, tests, and then look for the different mocks in here. So mock Oracle, VRF coordinator mock, etc. So I'm just gonna grab it though from this Chainlink mix. So let's go to VRF coordinator mock, and I'm just gonna grab this whole thing here. So do contracts, new folder, test, new file, VRF coordinator mock.sol. Paste it in here. And then while we're in here, we'll want to do a new file, mock v3 aggregator.sol. We'll grab this as well from our Chainlink mix. Again, it's got all the functions of a price feed, update answer, latest round, etc. VRF coordinator mock has different functions for actually working with the VRF coordinator. One of the specific ones in particular is this callback with randomness that we're going to use in our tests. So our VRF coordinator is going to get mapped to our VRF coordinator mock, which will also import this from Brownie. Great, and just to double check everything's working, we'll want to run just a quick Brownie compile to make sure we are importing our mocks correctly and everything's compiling, so it looks like we're good there. All right, so now we have get contract VRF coordinator.address. Perfect. What else do we need in here? We need a link token. The Chainlink token is, of course, just another smart contract. So we're going to do the exact same thing here. Get contract link token.address. Of course, this means in our config for RinkB, let's add a link token address. We'll go to the Chainlink documentation. We'll go to link token contracts. We'll look for RinkB. We'll grab this address. We'll drop it in here. Perfect. Now we have it in our Brownie config. We'll also need to add it to our helpful scripts. So we'll need a mock link token, which again, we can just go ahead and grab from our Chainlink mix here. So we can go to test. And as you can probably see, what I often normally do is literally just copy this entire test folder project to project. So I'm going to copy this whole thing, create a new file. We're just going to call this one link token.sol, contract link token, perfect. And then in our helpful scripts, we're going to have this be link token. And of course, we're going to import this from Brownie. Great, get contract link token.address, perfect. What else do we need? We need a fee and a key hash. So the fee and the key hash are both just numbers, right? These aren't actually contracts. So we don't need to put this through that get contract bit. What we can do is just in our config, in our development network, we can just add a default for the key hash and for the fee. I'm just going to set my development key hash and fee equal to the Rinkeby ones. So to grab those, we'll go to the Chainlink docs once again. We'll scroll down to using randomness, contract addresses. We'll look up Rinkeby. We'll grab the key hash here, which we'll paste in for both our development and Rinkeby. And then the fee, it says 0.1 link. So we'll just do that in way here, which will be 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7. And we'll do this line for Rinkeby as well. Now in our deploy lottery, we can just grab this directly from our Brownie config because we're always just going to have this default key hash and this default fee here for our development network. So we'll do config networks network.show active. Which one's first? The fee. Fee. Of course, this means we're going to have to grab network from Brownie and also config. Then we'll do config networks network.show active key hash. And then of course, our last bit here, from account. And then additionally, as we learned last time, if we want to publish this, we'll do publish source equals config networks network.show active. We'll say .get verify, and then we'll add this false bit here. What this is saying is get that verify key, but if there's no verify key there, just default to false. This way, if we don't set a verify key in development, that's fine. It just won't get verified. For Rinkeby, let's go ahead and set verify to true. So we can actually verify this on the Rinkeby chain. And then we'll even do a print statement here. Deployed lottery. All right, lovely. Let's try this out. We'll do Brownie, run scripts, deploy lottery.py. We won't set a network flag, so it'll go to the default development network. Let's try this out. Things are compiling. Ganache is spinning up. It looks like we did run into a little issue here with our get contract function. Of course, we forgot to add deploying these mocks in our deploy mock script. Whoops, let's go ahead and add that as well. Right now, our deploy mocks only deploys the mock v3 aggregator. So let's add the rest of our mocks in here. We're going to need to deploy a VRF coordinator mock and a Chainlink token mock. So let's open up those contracts, see what they need. The link token for a constructor doesn't have a constructor, so we can just have it be blank. So we'll do link token .deploy, and all we need is a from account here. And then let's see what that VRF coordinator mock takes. VRF coordinator mock. It takes the link token as an address. Perfect. So then when we deploy the link token here, we'll say link token equals link token.deploy, and then we'll do vrf coordinator mock dot deploy, and then we'll use the link token dot address as an input parameter, and then of course from account. All right, so now we're deploying all three of those mocks right away. Let's try this again. Brownie run scripts, deploy lottery.py. Ganache is spinning up. Perfect. So we can see here that our mock v3 aggregator was deployed. Then our mock link token was deployed. Then our mock vrf coordinator was deployed. And then our lottery was deployed with those mocks defined. And we deployed the lottery. Awesome. Now we could 100% go ahead and then run this script on an actual testnet, right? Because our config is set up well. Let's write some more functionality for actually interacting with this lottery before we actually do that. And then we can actually just run a script which will do all this functionality end to end. Because again, deploying to a testnet takes a long time, and we really only want to do that when we're done and we're fairly confident that everything's working well. Let's even just delete this here. So now what's the next thing that we'd want to do here? What's the next thing we want to do in a script here? Well, we probably want to go ahead and start the lottery. So let's write a script that can actually do that. We'll do def start lottery. And in here, we'll get our account equals get account. We'll say the lottery is going to be the most recent deployment of the lottery. And we're going to call this start lottery function here. This is indeed changing state. So we do have to make a transaction. We'll do lottery. That's start lottery. We'll say from account. And then we'll do a little print and just say the lottery is started. And then in our main function down here, we can even call this start lottery function. So if we run this again on our development chain, we'll see if everything works smoothly here. Okay, we did run into an issue, and this is something that you'll see from time to time. Typically the workaround is you want to wait for that last transaction to actually go through. So we'll say starting transaction equals lottery.start lottery. And we'll do starting transaction.wait 1. Brownie sometimes gets a little confused if you don't wait for the last transaction to go through. So let's try it again, and perfect. We do get this working as intended. So that is a really helpful tip if you run into those weird issues. You'll notice that even when we didn't have this, it still completed successfully. It just got a little confused at the end. All right, cool. So what do we want to do next? Well, we probably want to enter the lottery. Let's do def enter lottery. So how do we enter the lottery? We'll say account equals get account. Lottery is going to be lottery -1. We need to pick some value to send when we call the enter function, right? Because we need to send that entrance fee with it. So we'll say value equals lottery.get entrance fee. And just to be safe, I usually will tack on a little bit of way as well, because sometimes it might be off by like 1 or 2 or something like that. So we'll do lottery.get entrance fee plus, maybe something like this, which is like barely anything. Then we'll do transaction equals lottery.enter. We'll do from account. We'll send a value, which will be value. We'll do tx.wait, and then we'll do print. You entered the lottery. And we'll do this enter lottery bit down here too. Enter lottery. We'll run this, see if our enter script is working appropriately. You entered the lottery, looks great. And let's do our last function here. We'll do def end lottery. Count equals get account. Lottery equals lottery -1. We'll make a transaction, which will be lottery.end lottery. Now, before we actually end this lottery, we're going to need some link token in this contract. Because remember, our end lottery function calls this request randomness function. And we can only request some randomness if our contract has some Chainlink token associated with it. So we're going to need to first fund the contract and then end the lottery. Since funding our contracts with the link token is going to be a pretty common function that we use, let's go ahead and turn this also into a helpful script. So let's go to our helpful scripts. We'll make a new function called fund with link. And let's have this take a couple of parameters. So first, we'll want to have a contract address, of course. We'll want to know who we're going to fund with link. We'll set a default account to being none. So if you want, you can send an account, but you don't have to if you don't want to. We'll also do the same thing with a link token. We'll say if you want to use a specific link token, you can. Otherwise, we'll just grab it ourselves. And then we'll also do a default amount, which we'll set to 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, which is going to be 0.1 link. So first, let's get an account. We'll say account equals, and we're going to do a little clever Python stuff here. We'll say account equals the account if somebody sent it, if account. So we're saying the account that we use is going to be this account thing if this account thing even exists. Otherwise, we'll call our get account. Otherwise, we'll just do our regular get account function. Then we'll do the same thing with the link token. We'll say the link token is going to be equal to the link token that somebody supplies as a parameter if they applied something as a parameter. Otherwise, we'll just do that get contract stuff that we did before of the link token. Now that we have this link token contract from our get contract function, which again is basically the equivalent of doing, this contract.fromAPI on our link token, pulling from our config or from our mock, now we can just call the functions on this link token. So we can say our transaction equals link token dot transfer. We're going to transfer token to the contract address with a certain amount. And of course, we'll do from account. We'll do tx.wait. And then we'll do print funded contract. And then we'll even return that transaction. I do, however, want to show you another way to work with this using the interfaces. Instead of doing this link token.transfer directly on the contract, we can use this interfaces section to actually interact with some contracts. So right now we have our mock link token in here, which is great because it has all the definitions and all the functionalities defined in here. Sometimes you're going to have contracts that you don't have everything. You don't have all the functionality, and maybe you only have the interface, maybe you only have some of the function definitions. So we can still interact with contracts with just an interface because, again, that interface will compile down to our API. So as another way of teaching us how to actually work with some of these contracts, what we can do is we can use the link token interface basically the same way as we use the link token contract here. So again, I'm in my Chainlink mix because there's already a link token interface in here. And this will compile down to a way that our Brownie package knows how to interact with these contracts. So if you wanted to, we could just grab this, go to our Brownie section. We'll do a new file in interfaces. We'll call it link token interface.sol. We'll paste it in here. Save my auto formatted here. And what we can do in our helpful scripts instead is transaction equals interface. And we can also just import interfaces right from Brownie. Interface dot link token interface. And we just need to give it a contract address. So we can say link token dot address. Or excuse me, we can say the link token contract equals interface dot link token interface, link token dot address. So this is another way we can actually create contracts to actually interact with them. So we saw up here this contract.fromAPI, which is great. This is another way we can do that exact same thing. So then we can just do link token contract.transfer, contract address, amount from account. So this is tx equals. So this is another way to actually interact with contracts that already exist. You're probably starting to see that Brownie has a lot of built-in tools that make it really easy for us to interact with contracts. If we have the ABI, we can just pop it into contract.fromABI. And again, with the address and the ABI, and then just give it some name. If we have the interface, we don't even need to compile down to the ABI ourselves because Brownie is smart enough to know that it can compile down to the ABI itself. And we can just work directly with that interface, which is incredibly powerful. For now, I'm going to comment these two lines though, and we'll just use the link token.transfer for now. Now that we have a funding script or a funding function, we can import this from our helpful scripts. From scripts.helpfulscripts, import get account, get contract, fund with link. And we can just call in our end lottery function, we'll do fund with link. And parameters, we only really need a contract address because the way we set this up, we'll just automatically grab a default otherwise. So we can say lottery.address, and that's it. And that's all we need. And then I know we're doing tx.wait right in the fund with link, but just to be verbose here, we'll get the transaction from the fund with link, and we'll do tx.wait here as well. And then once we're funded with link, then we can go ahead and call our end lottery function, because again, this is going to call that request randomness function from the Chainlink VRF. We'll do ending transaction equals lottery.end lottery. And all we have to do is from account, do ending transaction.wait 1. So from our end, this is really all that we need to do, right? But remember, when we call this end lottery function, we're going to make a request to a Chainlink node, and that Chainlink node is going to respond by calling this fulfill randomness function. So we actually have to wait for that Chainlink node to finish. Now, typically it's within a few blocks. So normally what we can do is we can just do a time.sleep for something like 60 seconds. And typically in that time, the Chainlink node will have responded. So we'll just do import time at the top, time.sleep, and then we can see who that recent winner is, if that Chainlink node responded with a recent winner. So we can say print f lottery.recent winner is the new winner. All right, now, of course, for those of you who are thinking ahead a little bit, you might be thinking, hey, well, there's no Chainlink nodes watching our local ganache. And you're exactly correct. So what happens when we add our end lottery function to our main function here? Do you think that we're going to actually get a recent winner back? Why or why not? What do you actually think? Well, let's give it a shot. We'll do Brownie, run scripts, deploy lottery.py. So we're doing a lot of transactions here. We've started the lottery, we're entering the lottery, you entered the lottery. We're sending some link token. Now we just called the end lottery function. While we're waiting here, this is when the Chainlink node would go ahead and start responding with our randomness. However, as you probably astutely guessed, there's no Chainlink node that's going to call this fulfill randomness function right now. So for our Grenache chain, this will hypothetically end with nothing, right? Because there's no Chainlink node actually responding here. 0 is the new winner. Of course, this means that the Chainlink node actually didn't respond because there is no Chainlink node on our local Grenache. For our testing purposes, we're going to figure out how to actually get around that and deal with that. Awesome. It looks like we have everything set up to be successful in our lottery here. But we want to do our due diligence. We want to make sure that our tests are really solid on a development chain before we actually test this on an actual testnet. So let's jump into some of these tests. We've already started with this test lottery.py bit here, but we're going to iterate on this and make this even better. Now, before we get into these tests, there's a couple things we want to talk about here. And that's going to be integration tests and unit tests. Unit test is a way of testing the smallest pieces of code in an isolated system. And we're going to use it to loosely define testing independent functions in our lottery contract. We also want to do what's called integration testing, which is going to be testing across multiple complex pieces. Typically, I like to run my unit tests exclusively on a development environment and my integration tests on a test net. This is really helpful because we can test the majority of our application, like we said, on a development network, and then still be able to see what actually happens on a real test net and see what happens on Etherscan and everything like that. Typically, what people do is inside their test folder, they'll create two different folders, one for unit and another folder for integration. Since for this demo, we're only going to have one file for both, I'm just going to go ahead and not create these folders, but it's a pretty common practice. Instead, what I'm going to do is I'm going to rename this. I'm going to hit enter to rename it. I'm going to do underscore, type unit for unit tests, and we're going to create a new file called test lottery integration.py. So this one will do our integration tests, and in this one, we'll do our unit tests. Now, when writing unit tests, we really want to test, hypothetically, every single line of code in our smart contract. This is incredibly important, of course, because smart contracts are open to everybody to see and interact with. So we really want to test every single line of code we have in here. So let's go ahead and finish writing a get entrance fee test that will work on a local development network. As you can see, we're already going to have to refactor this from what we originally had. Let's go ahead and just delete everything under here for now. We already learned so much more from there. All right, so how are we going to test this get entrance fee function now? So first, we're going to want to deploy our lottery again. Since we have a deploy lottery script already, we can just use this deploy lottery script as well. If we wanted to, we could just copy paste this whole part into our test, but we're just going to go ahead and work from this deploy lottery script. So we're going to import this, and then we can actually even get rid of this from Web3 line for now. We can get rid of these two comments too. And we'll say from scripts.deploy lottery import deploy lottery. And on this deploy lottery function, we'll just say lottery equals deploy lottery, and we will return our lottery. Now, in a unit test, we'll say lottery equals deploy lottery. And this will give us our lottery contract. Once we have our lottery contract, we can just call this get entrance fee. So we can say entrance fee equals lottery.get entrance fee. And oops, let's just make sure we're doing the arrange act assert mentality here. And we're going to want to make sure this entrance fee is what we expect it to be. So what do we expect it to be? Well, again, our helpful scripts is going to deploy these mocks, right? It's going to deploy this mock, and the initial value is this 2000 number. So if the price of ETH here is $2,000 ETH/USD feed, and the USD entry fee is 50, we would say 2,000 over 1 is equal to 50 over X, which is going to be equal to 0.025. So we can go ahead and even do this math here. We can say expected entrance fee is going to be equal to 50 divided by 2,000. We'll just do 0.025, but we'll do this in way. So we'll do from Web3 import Web3. We'll say this is Web3.2 way 0.25 Ether. And now we'll assert our expected entrance fee equals the entrance fee. And now to test this, we'll do brownie test-k. And perfect, this is working exactly as we anticipated. So that's awesome. Now, as we mentioned, since this is a unit test, we really only want to run this when we're working on a local environment, a local blockchain environment, or a local development network. So we'll go ahead and do this with PyTest again. Say if network.showActive is not in local blockchain environments, PyTest.skip. Of course, we're going to have to import PyTest. We're going to have to import this local blockchain environments from our scripts.helpful scripts. My VS Code automatically added that bit here. Now, if we try to run this, brownie test -k get entrance fee -network rinc eb. It should go ahead and skip this. Perfect, and that's what it does. What's the next piece that makes sense here? Enter is going to be one of the first things that these developers do. So let's do test def test enter. But let's even be more specific than that. We don't want people to be able to enter our lotteries unless the lottery is actually started. So let's make sure that this line actually works. So we'll call def test can't enter unless started. And again, we're only going to run this on a local development chain. So we'll just copy paste this section down here. We'll say lottery equals deploy lottery, because we're going to want to work with the lottery. And now we're going to want to, that when people try to enter a lottery that hasn't started yet, it's going to revert. So we can use what we've used before. We'll say with pytest.raises exceptions.virtual machine error lottery.enter from get account value lottery.get entrance fee. Of course, we're going to have to import both get account from our helpful scripts and exceptions from Brownie. Perfect. And this as well is following the arrange. And this is actually act/assert. So let's go ahead and test this. Brownie test-k test can't enter unless starter. Oops, let's do start ed. And great, that's passing as well. Let's go ahead and keep going down this list. What else? Now that we've tested whether or not they can't enter, let's test whether or not they can enter. So we'll do def test can start and enter lottery. So we're going to copy this again, paste it down here since we're going to work on a local blockchain. We'll do lottery equals deploy lottery. Account equals get account. We'll start the lottery, lottery.start lottery. We'll do from account. We'll do lottery.enter from account. Say value is lottery.get entrance fee. And then we'll assert that we've correctly added a player to this lottery. So we'll assert lottery.players of 0 is going to be this account, right? Because we have our players array, and we're going to assert that we're pushing them onto our array correctly. Lottery.players of 0 equals account. So here's our act, and here's our assert. So let's try this now. Brownie test-k test can start and enter lottery. And once again, awesome. Things are looking great. Now let's test to see if we can actually end a lottery. So we've tested we can start a lottery. So we'll do def test can end lottery. We're going to copy this again, paste it down here. We'll do lottery equals deploy lottery. Account equals get account. We'll start the lottery with lottery.start lottery. Now we could 100% just import the rest of these functions in here, like end lottery, enter lottery, and start lottery. And similar to how we're just doing lottery equals deploy lottery, we could absolutely do that. For being very verbose here, I'm just going to go ahead and write all the functions and transactions myself. And this way, we'll actually be able to test a little bit more granularly. Anyways, we'll do lottery.start lottery from account. We'll do lottery.enter from account. We'll give it a value, lottery.getEntrance-fee. Oops, I'm going to have to do account course equals getAccount. Now, to actually end the lottery, we do need to send this some link because we're calling request randomness. We use our fund with link script that we have in our helpful scripts. We'll import this from our helpful scripts. We'll call fund with link on our lottery contract. Once we fund with link, we'll then call lottery.endLottery from account. And then how do we actually know that this is being called correctly? Well, if we look back in our lottery contract here, when we call end lottery, we're not really doing a whole lot. All we're doing is changing our state. So let's go ahead and check to see if our calculating winner state is different. So we'll say assert lottery dot lottery state is equal to what? So calculating winner, if we scroll up to our enum, is in position 2. Open is 0, close is 1, calculating winner is 2. So we can say assert lottery.lottery state equals to 2. We can go ahead and test this as well. We'll do brownie test-k, test can end lottery. We'll see if this works. And it does. Now let's test the most interesting piece of this entire lottery contract. We're going to test whether or not our fulfill function actually works correctly. Does this correctly choose a winner? Does it correctly pay the winner? And does it correctly reset? So let's go ahead and build our most complicated and most important test of this whole contract, choosing the winner. We'll do def test can pick winner correctly. Let's copy paste this bit about getting started. We'll do lottery equals deploy lottery. Account equals get account. We'll do lottery.start lottery from account. And then we'll enter with a couple different players. We'll do lottery.enter. Well, let's say from account value lottery.get entrance fee. Lottery.enter. And we'll copy this 2 more times, but instead we use some different IDs. We'll do index equals 1, and we'll do index equals 2. These are going to be different accounts here because we're going to use a different index because we want to just test for multiple different people here. This unit test is getting drastically close to being an integration test, but as I said, we're being a little bit loose with the definitions here. Now we're going to want to fund it with link, so we can just go ahead and copy this line here, fund with link lottery. And now we're going to want to choose a winner here. And this is where we actually have to modify one more thing in our lottery contract. So in order to test actually calling this fulfill randomness function and testing everything in here, we're going to need to call this fulfill randomness function. Now, if we look at our VRF coordinator mock, we have this function called callback with randomness. And this is the function that actually calls this raw fulfill randomness.selector, which eventually will call that fulfill randomness function. But this is the entry point that the node actually calls. We have to pretend to be a chain link node and call this function. We're going to return a random number, of course. We're going to choose the contract we want to return to, but we also have to pass the original request ID associated with the original call. Now in our lottery contract, our end lottery function isn't going to return anything. And even if it did, it would be really difficult for us to get that return type in our Python. So what we want to do to keep track of when this contract actually entered the calculating winner state is we want to do what's called emitting an event. Events are pieces of data executed in the blockchain and stored in the blockchain, but are not accessible by any smart contracts. You can kind of think of them as the print lines of a blockchain or the print statements of a blockchain. We can go to this logs section, which also includes all the different events. Now, there's a lot of information here, so we're actually going to do an event ourselves just so that we can see what this really looks like. You can see here that when we call this end lottery function, in the logs, if we scroll to the bottom, there's an event here called randomness request. This was spit out by the VRF coordinator. This was spit out by the VRF consumer base that we inherited. And it even has some data that's already been decoded. One of those pieces of data is the request ID. Now, to add an event, we first need to create our event type. So at the top, we'll go ahead and do event requested randomness. We'll say bytes 32 request ID. So now we've identified a new type of event called requested randomness. It's really similar to the enum in this regard. To omit one of these events, all we have to do in our end lottery bit is we'll do omit requested randomness and then request ID. Because requested randomness takes a bytes 32 as an input parameter, and we're going to pass it that request ID as an input parameter. Now that we have this event being omitted, back in our test, when we call end lottery, it will actually omit one of these events to our transaction. So what we can say then is transaction equals lottery.end lottery. Same way we've always done it. But now we can look inside of this transaction object. Inside of this transaction object, there's actually an attribute called events, which stores all of our events. We can then look for a certain event name, which we know is requested randomness. So we'll say, out of all the events, look for the requested randomness event. And in there, in that requested randomness event, find the request ID. Request ID. Now we can say request ID is going to get grabbed from this event that we emit. So these events are going to be really helpful for writing tests. These events are also really helpful for a number of other reasons. One of the big ones is upgrading our smart contracts or understanding when a mapping is updated. But for now, we're going to be using them for testing. Now that we have this request ID, what we can do is pretend to be the Chainlink node and use this callback with randomness function to dummy getting a random number back from the Chainlink node. So what we're going to do is we're going to call our getContract function and get that VRF coordinator. Of course, we're going to have to import it from our helpful scripts. And we're going to call that callback with randomness function. So we're going to do dot callback with randomness. And we need to pass it this request ID, a random number, and then the contract to return to. So we'll do request ID. We'll do some random number, like we'll say static RNG equals 777. So we'll say the random number that we're going to return is going to be 777. And then we'll do lottery.address because we're going to return it to the lottery. Once again, we're going to say from account because this is making a state change. And now that we've got a callback, what we can do is do our asserts now. So this is us dummying getting a response from a Chainlink node. And this is how we mock responses in our tests to make our lives way, way easier. So now we can figure out who the winner of this lottery actually is. If these are our three entries, that means it's 777 mod 3. Since our random number is going to be 777, if we pull out a calculator, 777 divided by 3, it divides evenly. So we know that this means the answer to this is going to be 0. aka our account is going to be the winner. So let's assert the lottery dot recent winner is going to be equal to our account, right? Because we set a recent winner in here. We transfer them some money. We'll assert lottery.balance is now 0 because we're transferring this account all of the money. And let's even make sure that the account gets more money, right? So we'll do starting balance of our account. Starting balance of account equals account.balance, account.balance, and we'll do balance of lottery equals lottery.balance. And then we'll assert account.balance is now going to be these two added together. Starting balance of account plus the balance of the lottery. Because we should get all of the lottery winnings here. Okay, so this is a long test, but this is probably the most important test. Let's make sure this is doing what we want it to do. So we'll do brownie test-k. Test can pick winner correctly. Let's see if this works. Oops, I forgot to put some parentheses here, some parentheses here. Let's try this again. And perfect. We are actually updating, paying out, and running our lottery correctly and fairly with true randomness. This is incredibly exciting. And we've omitted events in our lottery contract to use in the off-chain event logging of Ethereum. I know we're getting antsy to actually run this on a real chain. So let's go ahead and do our last bit here. We'll create our integration test, which we will run on an actual chain. And then if we wanted to, we go ahead and try our deploy lottery function on a real chain as well. All right, so let's do our integration test here. This is where we're going to actually test on a real live chain. We're going to use Ringpy because that's the network that we've been using this whole time, which is great. Now, I'm being a little bit liberal in the way that we're doing our tests here. And we're just going to do one test for this integration test, but keep in mind, you're going to want to test every piece of your code. So let's just create a test called def test can pick winner. Now, this is going to be the opposite of our unit tests. Our unit tests are only going to be on our local blockchains, right? We're going to skip if it's not on our local blockchains. We're going to do the opposite of this one. So we can even just copy this, or we can type it out. We'll say if our network.showActive is in those local blockchain environments, then we're going to do pytest.skip. Of course, since we're grabbing these pieces, we're going to do from brownie import network. We're going to import pytest. And we're going to do from scripts dot helpful scripts import local blockchain environments. We're going to deploy our lottery. So lottery equals deploy lottery, which we're just going to grab from scripts dot deploy lottery import deploy lottery. We'll do account equals get account. Of course, we're going to grab that from our helpful scripts as well. So we'll do lottery dot start lottery. This will be from account. We'll do lottery dot enter. Say this will be from account. We'll do some value, which is going to be lottery.get entrance fee. And if we run into an issue here, sometimes, again, we can do lottery.get entrance fee plus like 100 or 1,000 or something like that. This is going to be barely anyway, but for now, let's keep it like this. Then let's just copy this line. Run it again. We'll have 2 people enter the lottery. Of course, it's going to be us both times. And great. Now we're going to want to actually end the lottery. So first we're going to want to fund it. So let's import that funding script. So we'll get fund with link, or that function. So we'll call our fund with link function on our lottery contract here. And then we'll go ahead and end the lottery. So we'll say lottery dot end lottery. We have to do this from our main account. We have to do this from the admin account. Now, this is where it's going to be a little bit different from our integration tests, or from our unit tests. In our unit tests, we pretended that we were the VRF coordinator, and we called the callback with randomness. We pretended that we were a chainlink node. Here, we're not a chainlink node because we're on an actual network, so we're actually just going to wait for that chainlink node to respond. So for simplicity, we'll just do time.sleep, and we'll wait like a minute for it to respond. Of course, since we're using time, we're going to want to import time right at the top. And then, since account was the only one to actually be in this, we'll do assert lottery recent winner equals account. And we'll also assert lottery.balance equals 0. All right, great. So we have an integration test that we can run, which is going to run through pretty much the vast majority of our functionality here. So we can go ahead and test this with Brownie. Test will be a little bit verbose here. We'll say -k, test can pick winner. And then, of course, we'll do -- network rinkb. Now, before we run this, per usual, we got to make sure, do we have any testnet rinkb Ethereum? We do. Great. Do we have any testnet Chainlink? We do. Perfect. Do we have a .env? We do. It's got all of our pieces. Let's check our Brownie config. .env. Awesome. And again, if you don't want to use the .env, you can use that other method that we showed you guys, how to encrypt with a password that you can absolutely use. Oops, and before we run this, let's set this to start lottery, because that's the actual function here. And we'll also need to be lottery.balance with parentheses here. Sorry about that. And now we can run Brownie test -k, test can pick winner, -- network rinkb. We'll also add this -s flag, which will print out whatever Brownie is going to be printing out. It'll make everything a little bit more verbose here. And if you want to, you absolutely should, because this is something that we'll have to do at some point anyways. However, if for this tutorial you want to skip it, go ahead, because we're actually going to run through this whole process of deploying and waiting again anyways. So now we've added all of our tests, what we can do is run our entire test suite. So we'll do Brownie test. And this is going to run through all of our development tests here. You'll see it'll go really quickly. And you see how much faster it is for us to run our test on a local chain as opposed to doing everything on a testnet. So it's going to make your life way easier. And we have everything passed here. So we know that our contract code is doing approximately what we want it to do. So it's time for the moment of truth. Let's deploy this to an actual testnet. So we have our deploy lottery script, which oftentimes I'll have it be just this deploy lottery bit, and then I'll have some other scripts for these other pieces, or maybe I'll do it in the Brownie console. But just to demonstrate everything end to end, we'll have deploy lottery, start lottery, enter lottery, and end lottery all in this one script so that we can see everything end to end and see what it looks like on Etherscan. So let's go ahead and run this script on a rinkb network, and then we'll go jump onto Etherscan and see everything. So let's do it. Brownie, run scripts, deploy lottery, network rinkb. So first, we went ahead and we deployed our lottery. We got our addresses with our get contract method. We got our fee, we got our key hash, we got our published source and everything here. Then we went ahead and verified it because of this published source. So if we grab this address, lottery deployed it here, we jump over to rinkb Etherscan, we paste this address in here, we'll see this contract with the little check mark is verified. And again, we'll go to the read contract. We can see all the public variables and all the public functions. We can go to write contract and we'll see all the transacting functions that we can interact with. After we get verified and things get deployed, we went ahead and called our start lottery function to actually start the lottery. We got our little print line saying the lottery started. Then you entered the lottery. We then funded the contract with Link so that we could get our random winner back. And then right now, our end lottery is confirmed. And we're just waiting this 60 seconds, right? Because we did this time.sleep. And if we sit on this contract, if we go to transactions and we refresh, we can actually see some of these different method calls over here. We can see we did a contract creation, we started the lottery, we entered the lottery, and then we recently ended the lottery. And you'll see in our script here, it says 0x blah, blah, blah is the new winner, which is perfect, right? That means that the chain link node actually responded. We can actually verify that by looking in the contract. We'll go to read contract. We can go to the recent winner and see somebody did indeed recently win. We can also go to events and we can see some of the events that we created. We can see this first event right here is this requested randomness event. This is the event that we called. We have this end lottery here. We can also see an ownership transferred function that got called. This was called when we actually deployed this in the first place. Now, a little bit more on these events, aka these logs, right? So topic 0, this hash represents this entire event right here. And this bit is going to be our topic 1, our first topic, which represents that request ID. So this is going to be the request ID. Awesome. We have successfully created a working smart contract lottery with true provable randomness. This is absolutely insane, incredible job here. Now, one additional piece that I want to talk about before we jump off here is, again, in our testing. A file that you're often going to see is what's called conftest.py. Python automatically knows to look for this conftest file, and we'll grab different functions from it. We can also add external plugins, fixtures, hooks, testing root path. It adds a lot of really fantastic features and is a common thing that you'll see. We skipped over it in here for simplicity, but in future projects, you'll probably see this conftest file, which has a lot of really nice testing configuration pieces in it. Now, that was a lot of stuff to code. And quite frankly, I don't think any of us want to have to do that every single time, have to code everything from scratch. Now, you can absolutely git clone all of these repositories right from their GitHub. But there's actually an even easier way for us to start with a blank project here. And this is with Brownie Mixes. So if we Google Brownie Mixes GitHub, we'll get this Mixes organization, which just has a ton of boilerplate code for us to go ahead, get started, and start developing. The one we're going to be working with is this Chainlink Mix piece, which is forked from this official one here. This gives us some wonderful contracts, some tests, a Brownie config, and really everything that we need to do to get started. So if you have Brownie installed, we can just bake this mix. So we'll do Brownie, bake, Chainlink Mix, and in our new empty directory here, we'll get this new Chainlink folder with everything inside of it. So then we can cd the Chainlink, and we can see it has all of these pieces in here already. In the contracts, we have a whole bunch of different samples of working with the VRF, working with the price feed, working with this thing called keepers to automate our smart contracts, and making API calls and delivering any API call that we want to the blockchain. It also has a Brownie config, which already has a number of wonderful pieces in each one of these networks so that we don't have to go copy paste and add it in here. It's even got support for testnets like Avalanche, Polygon, Binance, and more. It has a number of really powerful tests, including testing some price feeds. It has a whole bunch of deployment scripts, some mocking scripts, some helpful scripts, and really everything that we need to get started and get going. For starters, we could run Brownie test. And it's going to compile everything. And then on a development chain, run all these unit tests. And if we wanted to test this on a real testnet, we could do Brownie test -- network ringp or any network that we wanted. If you're looking for a good starter place that has a lot of really powerful smart contracts for you to get started, I highly recommend using this mix as a boilerplate starting point for any of your contracts or any of your projects here. Now we are cooking. So we've learned a ton of the fundamentals of working with Brownie and working with smart contracts. Now that we have kind of all the building blocks though, we